French scientists and people that made an influence from France. France played a huge role in mathematical advancement and also physics. There's a whole book I have on Western civilizations, and this week I almost wanted to change the name to Western Civilizations Camp / French Camp. But the French played a huge role in mathematics, in chemistry, in engineering, and in physics, okay? They played a huge role thinking about the 1600s. At this point, we didn't have calculus. We didn't have Newton yet. Newton was born, as I said, in 1642 on Christmas Day. He was like a present to the world, even though some people don't like him, but he was a present to the world. Newton was born in the year that Galileo died. Galileo was the boss. And then Newton came in 1642. So Galileo dies, Newton takes over. Newton goes to college to study law because there was no physics. Why? Because Newton hadn't existed, right? Isn't that weird to think about? There was no physics major. He went to a university, Cambridge University, which is about 2 hours from Oxford University. By God's grace, we plan to keep the Oxford-Cambridge tour on its own thing, on a certain rotation. So if you ever want to go to Oxford or Cambridge, let us know. We'd love to show you. Every time I think of Oxford, I just have great memories. Oxford is great. Cambridge, I have some good memories, but they had too many gates locked, so I need to talk to some people and get more gates open. But basically, Newton goes to college. In 1661, there's a plague. Think about COVID equivalent, okay? It's a plague, and people go home, and everybody goes back. And during some of that time, they had Isaac Newton does some work, serious work, which gives rise to a lot of things we teach in calculus and physics today. So when you have, I think the Black Plague might have been 1300, so I think we call that a different name. Yep. So in 1661, they have this plague. Newton goes back, discovers some great things. We had the COVID pandemic in 2020, and people were trying to break the internet watching movies. It just tells you the difference in perspectives, right? So it tells you the difference in perspective. Okay, so now let's go ahead and write. So we have 1. So I'm just going to write down the answers that you guys had. So 1, and then we had, let's write down the numbers. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 2 squared was 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. This was not part of my secret for you, but I do want to tell you guys a secret that you guys don't know, and I need you to know that. If you multiply 11 by any number, you actually just need to add the digits that make up that number and put the answer in the middle. So what is 11 times 12? What is 1 plus 2? 3. So just put the 3 in the middle. So when you multiply 11 by a number, just add the digits and put it in the middle. So what's 11 times 11? It's going to be 121 because 1 plus 1 is 2. You put it in the middle. What's 11 times 24? 11 times 24 would just be 264. How do I know that? Because you add those two numbers and put it in the middle, okay? So here's my take on math when it comes to math instruction. Math is beautiful. I hope we can agree with that, even if we don't maybe always appreciate some of it, how math works. But math is beautiful. But here's the catch. No matter how good you are in math, there's always room to be better. I have tutored students who went to college at 19 for PhD programs and all of that. And I've tutored students who were getting Fs. And I've worked with students on the whole spectrum, okay? And here's my main thing I will tell you. And even myself, I'm trying to take advanced math, just for fun. Everybody can get better at math. You know why? Math has so many unsolved problems. So even if you're the best, the best in math today, one of the best people in math today is a man by this name, okay? This is his name, Terence Tao. So we've talked about the people of the past. Well, who is the person today? Well, this is one of the names that would come up. And he actually has a free course online, which I need to finish watching, a masterclass. But imagine if you could sit down. Now, I'm not going to put him necessarily at the level of Newton, but let's just use that for a second in terms of the best of the season. Imagine if you could sit down with Newton and have him teach you. Wouldn't that be cool? Well, the closest thing you can get is a UCLA professor named Terence Tao, right? Now, what if you don't want to be a mathematician? What if math is not your cup of tea? Well, I will tell you this, and then we'll take a break, a 5-minute break. I'll tell you this. I will tell you that math is the gateway to almost any profession that really carries weight today. Like, even if you want to be a nurse, I've had people that, oh, I went to school, then I didn't want to do math, and now I want to go to nursing school. And guess what? I'm getting calls saying, can you help me tutor statistics? I need to go back and get my nursing. It was like, but you should have done it back long ago, right? But I didn't think I needed it. Well, here's the catch. Nobody knows what they need. But here's the problem. You don't know what you need when you're in middle school, but then you get to graduate, and then you realize, oh, but I need that. Now, guess what? It's kind of too late. But if I just do it now and do it well, guess what? If I ever change careers, I'm fine. If you take calculus, you are fine for almost any field, except if you want to become a physicist, a chemist, an engineer. If you want to become a physicist, a chemist, or an engineer, then you will have to take Calc 2, Calc 3, and more math. But if you just want to be fine and cover your bases and say, I'm good, take calculus. I had a student one time, he had a free opportunity to take calculus. And he's like, oh, I'm not going to do it. He got a Division I scholarship to play basketball. He went on to his college, settling down, and guess what they asked him? So where's your Calc 1, please? And then he's like, oh no, he was right. So then he had to take Calculus 1 when he could have done it for free long before in his school. But he didn't know that, right? He was young and all of that. So my point is, if you can, take Calc 1. Everybody get that? We're on the same page? Okay, now, you don't have to take it now. I'm just saying plan to take it. So this is how you work with 11s. How do you work with 10s? You just add a 0. That's all you do when you multiply 10. You just add a 0. And if it's 1,000 times 5, it's 5,000 because you take all the zeros from the 1,000 and add it there. So we've done the squares here. Now I want to show you something. What is 4 minus 1? 3. Okay. What is 9 minus 4? So do you see what I'm doing? I'm taking this minus this to give me that number. Everybody see that? So this minus this is that. Everybody get that? So then this minus this is 5. This minus this is
7.
This minus this is
9.
This minus this
11.
Okay. Without me asking you what the differences are, what is the next number that will be here?
13.
Okay. And the next number?
15.
Okay, and then the next number?
17.
And the next number?
19.
Okay, you've caught a pattern. There's a pattern. You don't even have to look at this. You know what it's going to be. That's part of what math is. Math is about pattern recognition. Once you get the pattern going, it will stay. Okay? So here we're going to have 15, we're going to have 17, we're going to have 19, we're going to have 21, and so on and so forth. Okay? In terms of the differences. And I'm sorry I've gone off. You have to do like this minus this is that. You get the gist, right? But that's the pattern it's going to follow. What is 5 minus 3?
2.
Okay. And this is going to be, right? So the differences are always going to be 2. Everybody see that? Okay. Just hold that thought for a second. I'm going to move over here. And for time purposes, I'm just going to do the cubes quickly. Okay, the cubes are 1, 8, 27. 4 times 4 is 16 times 4 is 64. 125, 216. Okay, 343. Okay, so that's the cubes for a second. Let's go ahead and do the same exercise. What's this minus that?
7.
Okay. Now, this one you will need your notes to quickly do the math. What's 27 minus 8?
19.
Sorry?
19.
Very good. What about these two?
37. 36.
36. So very close. Good job, Caitlin. And good job. Let's go ahead. What's the next one? So which one did we just do? So we did 7. Someone have a calculator. This part we don't have to do in our heads. Okay, let me do this part quickly. The goal is to show you what the pattern will be. Okay. So we did
61.
that. So what's this one?
Oh,
Oh,
36.
Caitlin was correct. I apologize. That was 37.
I was about to talk.
Okay. What about the next one?
61.
Are we 100%? I'm going to take your word for it if you on that one. So we're going to take 125 minus 64. Very good. What about 260 minus 125? So we have 91. Okay. Now, what is this difference? 19 minus 7.
12.
Very good. What about that difference?
12? No. No, not 12.
18.
Very good. What about that difference? The next one.
24.
Okay. Are you gonna notice a pattern?
Mm-hmm.
What's the next number?
30.
And then 36. Okay. 18 minus 12.
6.
Okay. If it hasn't settled in yet, watch what just happened. When we took the squares of numbers, we found that there was a pattern of odd numbers going from, because I could do the 0 and 1 here, and technically that would just be, 0 squared is 0 here, and 0 to 1 would give me 1. So basically, the difference between the squares ended up being 1, 3, 5, 7, 9, 11, and then the difference of the difference became an even number 2, all across the board. When you do cube of a number, you do the cube, right? You got the cube here. The difference between them was, we got 19 minus 7 and so on. We started getting a pattern of 12, 18, 24, 30, and so on. The difference of the difference was 6, and it's always going to be 6. I'm going to repeat this in another video someday if you want to go back and watch it, because this might take a second to settle in. But here's the catch. If I wrote down the 1 to the 4th, 1, 2 to the 4th, 16, 3 to the 4th, so we have 3 times 3 times 3 times 3, 81, 4 to the 4th, and I did the same exercise I just did, we will get to a point where we have a pattern also established. Has everybody seen what's happening here? The difference of numbers when they're squared will give a certain pattern. The cubes of numbers will give a certain pattern. And when you go home, try this out. Go all the way to 12, find the difference between each of the numbers leading up to the next one, and then do the difference of the difference, and do the difference of the difference until you get to an even number, or a number that is stable all across. Does that make sense? I thought I had discovered something a few years ago. So I did this, I found this out. And I thought to myself, this is great. We should tell people about it. This is exciting. And then I discovered somebody else did that before me.
How long ago did somebody figure that out before
In
you?
the 1600s. Isaac Newton discovered that and actually gave us a formula for it. You don't have to do all this work. There's a formula that'll tell you the answer like this. This work we just did, I could tell you what it's going to be. If you raise the number to the 10th power, I could tell you what that pattern will be. If you raise it to the 100th power, I could tell you what that answer is going to be because of Isaac Newton. How did he do that? He said, well, I don't know if he intended for it to be that way, but this is what his formula does. His formula says, let's say n to the x. Okay, this is his formula. His formula says, if you were to take a number and differentiate the number or the function, so for example, x squared. If you take x squared, which is what we did over here, every time you were squaring the number, that's basically x squared. So if this is x squared. If you were to square the number, then it gives you a certain value, right? So 1 times 1 is 1, 2 times 2 is 4, and all that, whatever. So this function is actually the function of x squared. Y is equal to x squared. Anyone ever heard of the word function before? Okay, so that's what they say. So y is equal to x squared. And if you were to differentiate it, so that's the word. If you were to differentiate the function, which is what calculus 1 is all about, you will get, using the formula, which I'm not going to go into detail about, you will get 2 times x. That means that if you were to square numbers and try to find the difference of the rate of change of those numbers, the constant is going to be 2. So we know what it's going to be at the end of the day. If you were to cube the numbers, the answer is going to be 6 times x. Again, I'm not going to show you the formula right now, maybe at the end. But the point is, if I used Isaac Newton's formula, it would have told me that this is what I would get. Like the formula tells you what the end product is of that pattern that you're trying to work out. Make sense? Okay, so let's end with this. Because we're not only talking about English mathematicians today, we're talking about the French. We're going to end with Pascal for your break. You guys will come back and we'll just wrap up with him. And this is the Pascal triangle. Okay, I'm going to stop here for a second. When I come back, I'll explain more. But basically, after the break, this is what Blaise Pascal, one of the things named after him, is a French mathematician, and they call it Pascal's triangle. But it's going to show us the beauty of symmetry of how these numbers work. In conclusion, math is about patterns. The English, the French, and the Germans gave us a bulk of mathematics that we teach today. When we come back after the break, we'll talk about Blaise Pascal. So let's go ahead and take about a 7-minute break, say hi to your friends, and then we'll come back and talk, okay? So thank you for watching all and listening to all of this detail. Sorry if this part got a little tricky. I was just trying to show you how we come up with patterns in mathematics. Sound good? Okay, there's no recording. The floor is open. You're welcome to run to the bathroom or say hi.